Okay, let's now continue with the subject about math models. Let's see what we have from last time. Okay, the concept is actually pretty easy. I just want to point to you some implementation issues over there, and then just point to you something you have to study by yourself. Okay, so let's just go there very quickly. All right, it's a very quick recap why we are doing the math models. Okay, it's very often that anything you want to implement for your application, possibly for your projects. Let's say as simple as a level stack. Okay, so you have a stack that will be last in first out over here. So there are three possible ways for you to implement this particular stack. It can be an array where the last element is the top, or it could be a linked list where also the last element in this the linked cell is the top, or it can be just another linked list where the first element is the top. Okay, we just got three different strategies. They're all linear. Just make it simple. What we learned from last time, which I wouldn't repeat, but I'll just tell you what we learned last time. We learned about if you try to implement the contracts and body of code using the three different strategies, you will actually violate the principle for information hiding and the single choice principle. That's what we talked about last time. So I'll leave to you to study, to review that. Okay, that's something you should really expect to answer, also to judge whether a design is good or bad. Okay, let's go a little bit further. Since we know we actually will violate the single choice principle when we go from one strategy to another, okay, because they simply represent different ways of accessing the underlying data structure. How can we actually solve this problem? Which means we want the contracts which appears in the public view to the clients. We want the contract to always look the same, and it doesn't really depend on how you implement the underlying data structure. How do we achieve that? The answer is you want to create some kind of abstraction. Okay, I will show you what abstraction really means. Basically, we want to support some kind of query, and the query is going to return some value that is converted from your underlying data structure. Let's see exactly how the query looks like. Okay, we already went through the details for this, but let me remind you about it quickly. Okay, so so far you have seen Lab 3 and Lab 4 using ETF. And the library called MathModels is exactly for this purpose. And you can feel free to make use of that for the projects as well. Okay? And also lab number 5 will be something about the math models. Okay. So I'll talk about the term abstraction function in just a moment with a diagram. But for now, let's review how the code looks like. So there are two ways you can make use of the math models objects. One is about, so you can see the math model, one of the type that we're going to use for illustration for this class. Okay, so one of the types we're going to use for illustration for this lecture will be sequence. So it's simply a linear sequence. Okay, so there are two possible uses for that. Use number one, we simply say we're going to create some empty sequence to begin with, and then we're going to go over the implementation at the moment. And the implementation can be an array or can be a linked list. In general, it can be any underlying data structure that's hidden from the clients. And then we want to say when we go through the implementation structure, we want to somehow just create some mathematical sequence accordingly. Okay? So now, let's say this. In the case of, let's say we are using strategy number 1, it is an array. Okay? If it is an array, that means we simply got a linear structure like that. When we go the across loop, go over element by element, what we will create, you can see there is a feature over here called append. You can definitely look at API to see the math model, what features are supported. I'm just showing you the standard one. Append simply means to insert at the end. And you can see this is apparently a command, which means it is going to modify whatever the context object is. And the result over here has the same type as the return type over here. There's a sequence. Okay? So what it will do is for the very first iteration, it's going to insert the first element in the array into the end of the sequence. The sequence to begin with is simply just empty, right? So now what we will do is we insert the first one there. So I'll say the first element is going to be Alan. Okay, that's the first one. And then we do the second one, do the second iteration, we're going to do append the second time. When we do the append for the second time, we're going to insert the second elements from the array, and we're going to do, for example, over here, Mark. And then the third iteration, we're going to have Tom. The pink one over here is simply just different objects. The implementation is an array over here. And the model over here is more like a query. Every time you call the model query, it is going to call this particular loop to convert whatever the implementation is into a mathematical sequence. In this case, if we try to convert from this array into a sequence, this is how the sequence looks like. Okay. Any questions so far? Okay, following? Okay. Now, what I would like to say is, you can see that if we move from strategy number 1 to strategy number 2, let's say. So now let's say the implementation has been changed from an array into a linked list, let's say, from strategy number 1 to strategy number 2, okay? In this case, the question is, can we still use the same block of code over here? And then expecting, you can see that over here, this particular array and this particular linked list, they are representing the same stack, right? But the only difference is the order that we are supposed to refer for the top will be different, right? For strategy number 1, it should be the last. And for strategy number 2, for strategy number 2, it should be the first. You know what? I think the pointer, for strategy number 2, it should be over here. You know, I just got the number messed up. I think this should be 2 and this should be 3. Okay? I think for strategy number 2, it should be, the top should be, should be the, what am I doing here? What I meant to write is here, sorry. I think this meant to be strategy number 2, and this meant to be strategy number 3. I just reversed the number. Okay, sorry about that. Okay. Basically, for strategy number 2, so let's say over here, let's consider this particular linked list. Okay, this is supposed to represent the same stack over here. Okay, now the question for you, if we simply just execute this block of code over here, we simply keep appending to the mathematical sequence, are we going to get the same model over here? No, right? Because we'll simply get Tom followed by Mark and followed by Alan. So we'll simply get a model that looks like this. So we'll get Tom followed by Mark and followed by Alan. So this model here and this model here are totally different. So that kind of loses the point of creating a model. Okay? So what we should do is, every time when you swap from one strategy to another, what you should do is you should really change the way you convert the implementation to the mathematical model. Okay? So what we said last time was, you can simply do, for example, rather than having, so append over here is for strategy number 1. Okay? Now we want to do for strategy number 2. So what we should do is, you can, for example, say prepend. So this is another feature that is supported by the MathModel class. Okay? So when we do prepend, what's going to happen here? What's going to happen is, for the very first iteration, we have Tom from the linked list. In which case, we'll simply, so this one doesn't really work, really. So for the first iteration, we'll simply prepend to the empty sequence. In which case, our Tom will actually appear over here. Okay? Now, for the second iteration, we'll do prepend again, right? Prepend the second element, which is Mark, to the sequence over here. So that means we get prepend, and we got Mark over here. And for the third iteration, we got Alan. So now, if you consider this particular one, green model, and the pink model, they are consistent, even though the underlying implementations are different. So guys, do you follow the point? The point is, if you look at the underlying implementation there, strategy number 1 versus strategy number 2, they look completely different because they treat a different sequence as the top. However, the model that we are trying to convert into, they look the same. If the model looks the same, what does that mean? That means we can simply refer just to the model in the contracts. And if we want to change from strategy number 1 to strategy number 2, or back and forth, we can simply just change the way we convert. We don't have to change the model itself in the contracts. Okay? Any question about this? Yes? It's mainly for the contract, yes. So the idea is, for example, for lab number 5, what I want you to do is, in your precondition and postcondition, again, you should not refer to any of your implementation attributes. You should only refer to the model. Okay, that's kind of the idea, right? So that if you swap from one strategy to another, you don't have to modify the contracts. Okay? Okay. Okay, guys, clear? Okay, can I go on? Are you okay? You look confused. You okay, right? Are you sure? Okay. All right. Okay, let me just show you one more thing. So this part over here is about converting. This part here is about converting from whatever implementation you have into the mathematical sequence. Okay. Once the conversion is done, okay, what you can do is now you can specify the contract, for example, for the push feature over here using model only. Okay. And I think we discussed this last time. Let me recap very quickly for you. If you look at the appended over here versus the append over here, the names look very related, but they are not the same feature, of course. The critical difference is the append on the above is actually a command, which means it modifies the states of the sequence that we talk about, that we are trying to construct. On the other hand, the appended over there, over here, this one here is actually a query. So what does that mean? Okay, let's try to understand this. So this one, first of all, is a query. Okay, what's the context objects? Let's look at that. Okay, so now if you look at that, you know what? Let me just write it out, and then I will make a better anatomy for you. So basically, we have old. I'm copying this line here. Old model over here dot deep twin. Okay, and then dot appended over here G. Let's try to analyze this particular call, okay? Let's see over here. First of all, you can see that over here, we have O keyword. And based on what we discussed before, whenever you have the O keyword, you have to see which expression it is applied to in order to know which expression will be cached before the feature is executed. In this case, tell me what would be cached before the feature call. Model.deepTwin, okay? Basically, this line over here is going to be cached. But what's this line exactly, okay? Model over here is simply just a call, like a conversion for the implementation before we try to execute the feature, right? So model, you can think about this is simply a call to the query. Okay, and if you try to look at, let me just try to highlight this. If you look at the orange part altogether, when you say old model.deepTwin, so what does that mean? That means you try to call the model feature, which is over here. You're trying to convert the implementation, whatever it is, can be an array, can be a linked list, before the feature is executed, and try to make a deep twin out of it. Okay, let's make it very concrete for you. Okay, let's say this. Let's just make it simple. Let's say we are talking about strategy number 1, okay? For strategy number 1, let's say we have before we push Tom, and also after we push Tom. Okay? So now let's say I'm gonna use maybe the green for the implementation. Before we try to push, we already have Alan and Mark in the stack, okay? Before that, we already got Alan and Mark. Okay, let's say that's what we have before the push. We want to push Tom, okay? And this is the current top, okay, before the push, okay? Now, if you look at that, what this will do, old model.deepTwin, is trying to basically create a model sequence based on this conversion routine and make a deep twin out of it, okay? So I'm gonna use red to say that. So what it will do is we're going to have a old model deep twin, and it is going to just point to a sequence that is going to follow exactly this conversion procedure over here, right? So we're going to get also Alan and Mark. It's completely independent because it's deep twin. Okay, so what's so good? It's before the feature call. Okay, now after the push, we know that the implementation is going to be, if it is correct, it is going to be something like, maybe you would say Alan here, and then you have Mark over here, and then you have Tom over here. That is the correct one, okay? And now, if you look at that, so where do we have this particular call? If you look at over here, the left-hand side, we also have a model call. So we have one call to the model before the feature is executed. We got another call to the model after it is executed. So we want to compare two versions of the model before and after, right? So now for this particular second version, so this is after. Push is executed. And so this model.deepTwin is before it is executed. Okay, let's see how it looks like. What it would look like is, it's going to be, well, in this case, since our implementation is simply just correct, so what we will get is, we simply get the new one. So this will be the new call, which is just model. And then we try to do, and what we will get is simply that Alan, Mark, and then Tom. Simply follow the conversion procedure just one more time. So now, in the contracts, what are we trying to compare? We are trying to say we have two models basically. Okay, let's see. We have one model over here, and then we have another model over here. So the two orange models. We want to say this one over here is basically almost like this one here, except that it is going to be having G appended to the end of that. Okay? So what does that mean? You can see that over here, you can see this model here. The appended over here is so-called a immutable query. So what does that do? When you say, okay, when you say this is the model over here, the old model, when you say appended G, what it will do is something like this. So when I say old model over here, the deepTwin dot appended, and what's G in this case? Well, since we're trying to push Tom, right? So it's going to be Tom. Okay, the appended Tom. What it will do is, rather than modifying this sequence directly, it is just going to create a new sequence. That's why it's called immutable. So what you have deal with an immutable object so far, for example, string in Java, is simply just immutable, right? You just create a new string. In this case, when we say model deepTwin, which is this sequence over here, the appended is just going to give you a new sequence. Okay? What it will give to you is just another one. It's going to give you just another sequence over here, and then you say Alan here, you have Mark here, and then you have Tom over here. Okay, that's the appended to. This is the final expression. And we are saying that the two are equal. Okay, we are saying that finally, this one over here is the same as this model here. They are equal. I'm going to give you one contradiction to see how we can capture implementation error in just one moment. But so far, are you okay with the flow? Okay, so far good. Let's see. So why is this useful? What if the implementation is actually wrong? What if it is wrong? Okay, let's do from the beginning. Okay, let's see if the implementation is wrong. What I would do is, you follow the case where no violation should occur. What I would do is, let me keep the old model deepTwin, the red one over there, and then I will just erase this part, and I'll do a second scenario for you. And hopefully that will be better. So now let's say this. Let's say there is something wrong with my implementation. Okay, let's say. If there's something wrong with my implementation, so that means rather than creating Alan, Mark, and Tom, it simply say the following. It grow the stack into 3. Now it's going to be Tom, Tom, and Tom. Apparently that's wrong. So we would expect that model contracts over here to actually capture the error. But how? Let's see exactly how. So what we'll do again, we're going to call this particular model.deepTwin before the feature call. We'll do that first. And then after the feature call, we're also going to call model once more. Okay? So what we will get is, for this particular model, what we will get is this. Okay, I'll write it down. So what we'll get is, I'll put orange here. So that's the model after the implementation. Now, what kind of sequence are we going to get? Well, it's going to be based on this particular resulting implementation, right? It's going to be Tom, followed by Tom, followed by Tom. So we're going to get Tom, followed by Tom, followed by Tom. Okay? So now, once more. This part, old model.deepTwin, is simply just this part over here. That's old model.deepTwin. And then, what happens if I say appended with G, which is Tom? what it will do is it's going to give me the following sequence. I'll write it down. What that will give to me is, over here, it's going to give to me just another sequence here. So I got already Alan and Mark. So this is model.deepTwin appended with the G, which is Tom over here. Okay, so what I get is I just get Tom. So now, which two sequences am I going to compare? Well, apparently it's going to be this sequence over here and this sequence here. Are they equal? Apparently they are not. You can see the discrepancy over here. So you can see this part is not equal and this part is not equal. Okay, so that means it's going to violate the postcondition. Okay. Okay, guys, any questions? Okay. Anybody is lost or you're fine? Okay, you're fine, right? Okay, good. Now, I want to just explain one more thing on the diagram, just to show you why we are doing this. Basically, don't lose the big picture. The solution is very general. In general, you may have different strategies for your particular application. And according to information hiding, you are allowed as a supplier to switch from one strategy to another secretly. Okay? When you swap your strategy, you don't want your contract view to be affected. To achieve this, you can say for every implementation strategy, I'm going to have a common model using the MathModel library. Okay? So sequence is just one example. We also got relation, we also got set. So you'll get a chance to practice them in lab 5. Okay? So now I want to show you a diagram over here. Okay? It's not complicated. It's actually quite, hopefully they will visually summarize what we have just learned. Okay? Now, I'm trying to show you how we can use a common model for the various implementation strategies. Let's say we talk about strategy number 1, where the end of the array is the top. We also talk about strategy number 2, where the front of the list is the top. Let's talk about the two strategies. Okay? And then let's focus on the push feature as an example. And for the strategy number 2, I also talk about push. Okay? Let's see exactly how things work. First of all, let's see the before and after states. This part over here is the before states. Before the push is executed. Okay? Similarly, this is also before the push is executed. Okay? Before the push is executed, what do? We simply do a conversion, and we say that we are trying to create an abstraction for the implementation. In this case, the implementation is simply an array. Array is implementation specific details over there. And what we try to do is we simply call the model feature, right? The model feature that we talk about, which is over here. Right? We simply call the model feature. In that way, we can promote the array into a mathematical immutable sequence. That's what we can do. Okay, that's in the before states. Similarly, you can see that in the before states for strategy number 2, we do a similar conversion, but the details from the conversion will be different. We're going to use prepend rather than append. So in this case, we are converting from a linked list into the same model type, which is also a sequence, right? So from the public user's point of view, you're just talking about a sequence. They don't really see the array or linked list. Okay? Now, what happened to the post states for the push? So now I'm going to use a different color here. So the orange part over here, this is after the push is executed, right? Either because we try to force some elements to the end of the array, or it could be in the strategy number 2, we simply try to put something to the front of the linked list. Okay? In that case, we also got some after states over here. So this is after the push is executed. And what do? In order to write a contract to compare the pre and post states, we compare the two versions of the model. Basically, old version.deepTwin and also the new version. Okay? How do we compare them? Again, we have to call the abstraction function, which is exactly what this model feature is called. Okay? So we just call model query here an abstraction function. Okay? And now what we do is we simply call that, and in strategy number 1, we just convert the modified version of the array implementation into the sequence. And then when we specify the post condition, we simply compare this version of the sequence before the change, and also this version of the sequence after the change. Okay? That's good timing, actually. Anyway. Are we okay with this? With the diagram? Well, if you're confused, please say something. Yes.
For strategy number 2,
yes.
We should still use appended.
Oh, we should use prepend. Oh, you mean for the contracts? No, that's a good question. The question is, let me say this. Let me just modify a little bit, annotate a little bit more details over here. For strategy number 1, the way we do the convert over here is we do append. Okay, over here we do the append. Okay, now for strategy number 2. And remember, for strategy number 1, as we said before, the model looks like this. Alan followed by Mark, followed by Tom. Okay, now what about strategy number 2? Strategy number 2 always put to the front of the list. That's why we can treat the front of the list to be the first elements, right? So now, what we should do is we want to make sure we can have the same contract as before. This is going to use appended for the contracts using model. And for strategy number 1, we also want to use exactly the same contract. That's the point, okay? So now what we should do is we should basically, rather than using append, we're going to use prepend over here. And prepend over here. And remember, the implementation for the model over here is completely hidden from the user. So that's for you as a supplier to actually change, which wouldn't affect the user. Make sense? Okay. Yeah, okay, it's a quick recap, okay? Basically, it doesn't matter how many strategy you have. The green part is a public view for the user. They have the same view to the same mathematical objects, in this case, the sequence. And the contract should always remain the same, okay? Remain the same between the two strategies. In order to really keep this to be the same always, you have to make sure every time when you swap your implementation, let's say from an array to a linked list, you have to change something in the conversion function. Okay? Okay, any questions? Are we okay? Julian, are you okay? Are you sure? Okay, good. Sorry, you might be terrified when I call your name, but anyway. Yeah, okay. Anyway. Guys, are you sure you're okay? Okay? Yeah, hopefully it will be clearer for you when you see lab number 5. All right. Let's now see what else we want to say for the math model. Two more things I want to say about the math models. One thing, I want to just show you how the final products will look like using math models. And then I'll just show you what you should really do for the further study to give you some guidance, okay? Yeah, for the math model. It's quite a big library, but I will tell you exactly what you should know for the lab 5 and also for the exam, okay? Now, I want you to show you one more thing over here. Now, what I want you to look at is look at the 3 versions together, okay? Don't be terrified. I will show you exactly what you should look at. So now we got 3 versions of the stack, okay? We got version number 1. This is going to use an array. We got version number 2, and we got version number 3, okay? We got 3 versions, okay? Now, let's focus on the public view first, okay? What I want you to do, let's say we focus on push for now. Push here, push over here, and push over here, okay? Convince yourself the tag postcondition pushed over here, and push over here, and push over here. They look exactly the same among the 3 versions, don't you agree? Specifically, you can see I got appended over here, I got appended over here, I also got appended over here. They look just the same, even though the underlying implementation strategy is different. One more thing to say, you can see the model type is just the same, just a sequence, the model type, okay, among the 3 versions. So what's really the trick? The trick is the way you define the model should be adjusted accordingly from one strategy to another. What do I mean? If you look at the model feature over here, let's have a look at implementation strategy number 1. So this is the implementation strategy for the array. Maybe I should use yellow. Okay, let me just tell you what you should look at. If you look at that, this is the one. This is one thing. And let me show you another one. Another one is simply over here. Strategy number 2. This is the implementation. Okay, create some empty sequence to begin with. And there's another one over here. Okay, I will call this conversion number 1. This is conversion number 2. And this is conversion number 3. So these implementation details for the conversion are completely hidden from the user, so they don't have to know when you change them. Okay, so we are still obeying the information hiding principle. Specifically, you can see that, let's say for strategy number 3 over here, where the end of the list is the top. So this means we simply do append when we run the loop. On the other hand, for strategy number 2, we simply do prepend. Right? That's where the difference is. Okay? Okay, you can also look at other contract for other features, right? Just using model. So what you will be required to do for lab number 5, you have to make sure every time when you do your, let's say, in short for the post condition, and I don't really have a precondition over here, but later on when you write any contract, you should always only refer to the model. You should not refer to any of the imp. Okay? Guys, questions? We okay? All right. Let's now go a little bit further. Okay. Now I want to tell you one more example over here about using the math models, and then I will leave the rest to you. Okay, let me just go to the math model over here. One more emphasis. So whenever you're trying to use any math model classes, for example, sequence, set, and relation, you always got choices between either using a command in the conversion function, or you can use a query for writing the contract. Yes. Yeah. Yeah. Oh yeah. So I would say don't worry too much about this. It's just like a syntax. Over here, we simply say it's always attached. Huh? Oh, I'm so sorry. Yes. I'm just saying for this part here, don't worry too much. Okay. Basically, you're talking about this particular line here, right? Yeah. So I would say for this one here, don't worry. So just to say somehow to really make the voice safety compiler happy, you have to say for this any type you're passing is actually attached type rather than unattached. Yes, but somehow for the generics, they may not be so consistent with themselves. For this one, you have to say this is actually attached. You have to say that. You actually run into some compilation error, I believe. But I would say this part here, you just can reuse it. But inside the class definition, what we said last time still apply. Just when you declare the header for the class generics, you have to follow this syntax here. Yeah, to say for this, whatever G type for the element of the stack, you want to make sure it is attached. Yeah. Okay. All right. It's a good question, but don't worry, this will not be in the exam. Okay, this part here of the syntax. Okay, so I want to do one more example with you. Okay, let me just show you what, how the lecture, the rest of the lecture slide will look like. Again, you got the difference between command and also query for the math models. Okay, so this part we already talked about. I want to go directly to one part of the lecture over here. Okay, so we have talked about it. So this one here simply just summarizes basically what I said. When you go from implementation strategy from one to another, you can still leave the contract the same. Okay? So now, this part of the lecture is kind of optional. I would say only if you don't feel comfortable about sets and relations. And because when you want to use the relation class in the math models, they got many concepts which you learned from 1019 or 1090 about relations. Domain, range, domain subtraction, range subtraction, right? Maybe that's something you learned in 1019. If you kind of forget about them, this is a convenient place for you to review. Maybe just have that side by side when you have to do your lab 5. Okay? So for that part, I'm just going to skip. I don't need to waste your time in the class. Okay? You can study them when you need it. I just want to give you one example. Okay? Like how you can do things together. Okay? Relation is quite a common class to use for the math models. Okay? I should just show you one example. Okay? So now let's just go to the test directly. Let's say we have a task called test relation. Okay? And now what we do is we simply say we have R and we have T. So we simply got two relations, R and T. Okay? You just simply say the type of the class. You can think about relations more like a database. Okay? With a key and value. And over here, we say that string is going to be the key and integer is going to be the value. Okay? Or we also see this is the key, or we say that is the domain of the relation. And also this is the value, or we say that's a range. Okay? Okay, let's just see some example over here. And how do you create a relation? You can think about a relation looks something like this. Okay, I'll give you one example here. So this is one possible example for a relation. So you can see that over here, A over here, B, C, A, B, C, D, and E, and F. So these are the first elements for every pair in the relation. They are simply just domain values. Okay, so they are the domain. Whereas the second elements over there, you got 1, you got 2, 3, 4, 5, 6, 1, 2, 3. They are simply the range. Okay, the first one is the domain, and the second one is the range. Okay, that's how you create a relation. Simply like a set of pairs. And a pair is more like a tuple of size 2. Okay, let's see some example here. So one way for you to create a relation, for example, I can create a relation R by passing an array of tuples, for example. You can see I just passed the tuples over here with different pairs. Okay, that's how I initialize in a relation. Okay, so now, and then I can simply create a relation from an array. I'll just give you one example over here. How do I understand this particular call over here? I want you to compare these two calls. One is r.subtracted. The other one is domain subtract. Okay, have a look at these two features over here. Let's call it number 1, number 2. Only a simple question to help you understand. Let's say this is number 1, this is number 2. Which one is a call to a command? Number 1 or number 2? A call to a command. Second one, right? Because you can see that, well, for the first one, it cannot be a call to a command because you're trying to assign whatever value it is returned to something else. So if there's a command, it cannot be having this kind of return value. Okay? So this is more like a calling to a query. And this is a call to a command. Okay? That's what it would do. Okay? And for this one over here, when I say r.domain subtracted, so what do I really mean? What that would do is r.domain subtracted is not going to modify r. Instead, it's more like an appended for the sequence type. It is simply going to create a new relation. Okay? How does it really create? What it would do is domain subtracted means I'm going to create a new relation, but somehow it is going to subtract all the domain values that is given by the argument value over here, which is ds. So what does that mean? What that means is if you look at what ds is, so ds over here is simply a set of string. Okay? In this case, I simply give it one single value over here, just a. Okay? Now, if you look at this particular relation over here, okay, just this relation, let me just clean it up and show you. Let's say this is our R. Okay? So now if I say, I'll put it here. If I say R dot domain subtracted, and then I will simply say conceptually ds, which will just be a. It is going to give me a new relation. So what would that give to me? Basically, it's going to give me basically the same relation as R, except that domain A will not be there anymore. All the pairs associated with A should not appear in the new relation. So what would that be? You want to try? So A1 should not be there anymore, right? So I should only get B2, C3, B5, C6, D1, E2, and F3. Agree? So that means A1 and A4, they should not be selected in the new relation. So what I would get is I will simply just get a new relation. I'll just say B2, C3, B5, C6, and I get D1, I get E2, and then I get F3. So that's the new relation that's returned from this, domain subtracted. Of course, you got other operations as well. You got just get a domain, get a range, how to get the inverse, how to get domain restricted, domain subtracted, the different operations. I'll leave them to you. Okay? That's simply just how you call the query. What about this one over here? Domain subtract. As you can see, r.domain subtract just stands by itself. So that means it's not really a query. There's no return value. What that means is, rather than returning a new relation, it is going to modify R directly. So what it would do is, if this is already R, let's say R is pointing to this particular relation, it will delete these two pairs directly from there. Okay? It's going to just modify R directly, rather than returning a new relation. Okay, that's a very quick overview for the relation. Questions about this? Okay, that's kind of the feature you will expect to call when you use the math models. Okay. Guys, any questions before I move on to other topic from math models? Okay, right? Good. Now, let's talk about a new topic. Okay, and it will be a little bit logical today, a little bit logic. If you like logic, today is your day. Okay. Okay, so for the math models, I'm going to leave everything else to you, but you can definitely just study the slides when you receive lab number 5. But for tomorrow, I'm going to give you the project first, okay, so you can start working on that. Okay, project's ready. I just need to release that tonight. Okay. Now, the topic is called subcontracting. Okay, so subcontracting basically is addressing the issue about how can you understand contracts when you have inheritance. Specifically, we say that for inheritance, you inherit the code from the parent class. But how do you inherit the contract for the parent class? In short, you do inherit the precondition and postcondition and also invariant from your parent class. But the way you inherit that is not like just verbatim. There's certain logical connection you have to understand when you inherit the precondition or postcondition and also invariance. That's something we want to talk about. Okay? Let's just get some aspects over here. So that's something we already went through in the beginning of the inheritance lecture. We say that there are different aspects for the inheritance. We already talked about how you can reuse the code, and also for substitutability, we talk about polymorphism, dynamic binding, right? We talk about type checking rules. But today, we're going to talk even further about subcontracting. Basically, how you can specify to say my particular instance for the subclass can be substituted for the parent class. Okay, that's something we're going to address today. Okay, subcontracting. And you have to know what's the runtime effects for subcontracting. Okay. So let's have a little bit of logic background. Okay, a little bit. Let's say we talk about two preconditions, P1 and P2. Let's define some terms which we're going to use. I would say the first two slides are the most important ones. Once you understand the definitions there, everything else is just more about examples, okay, and some facts about the language design choice for iPhone. Let's say we got two P1 and P2. P1 and P2 are simply just Boolean conditions or predicates, okay, just Boolean conditions in your iPhone code. Let's say that very informally, and I'll show you how you can understand it in some formal way. We say that P2 over here, the second precondition, require less than P1. So what's really the purpose for precondition? Precondition is really for you to restrict some invalid input values. If you say a particular precondition P2 is requiring less, that means it is more tolerant on the input value. It can allow more values to be accepted for your future execution. Informally speaking, that's what it means. And now, how can we formulate this? Okay. I'll give you a little bit hints. I'm not sure if that's either in 1019 or 1090. When you talk about subset relationship, right? How do you define subset relationship using two predicates? If I say one set is a subset of the other, so what should be the corresponding relation for the corresponding predicates? Okay, I'll just show you the relation. It's good for you to think about it, okay? Maybe you're still waking up from 1019, right? Hopefully you are, okay? Let's have a look at this, okay? I'll give you an example, but just a little bit formality here. If you look at that, overall, we have a subset relation over here, right? We have a subset over here. We are saying that every element in this left-hand side set here is also an element on the right-hand side, but not vice versa. Okay? Now we are saying that the left-hand side set is defined as follows. We're saying that the left-hand side set is called set comprehension notation, right? Which you learned previously. We're saying that every element that is going to satisfy the precondition is going to be collected in this set. And it's going to be included in another set, which is defined by P2. And since we know P2 is more tolerant, it's requiring less, so that means potentially this set should be at least as big as the one for P1. Guys, make sense? Okay. So now, but that's not something you would like to, that's the kind of intuition you want to get. But let's say typically when you define your IFO preconditions, you want to know which one is actually more tolerant, which one requires less. That's not a notation to think about. You want to use some logical implication over there. So now, if I have that over there, so what does that really mean? Does that mean P1 implies P2 or P2 implies P1? P1 implies P2, right? Hopefully that's maybe some axiom or theorems you prove in 1019. Let's not bother with proving it, okay? If I have this, so this subset relation here is for you to get intuition. So P2 is more tolerance on the input values, okay? And now, and equivalently, you can simply say P1 implies P2, okay? Let's have one example. Let's say this. We have our withdraw command, and the withdraw command simply takes some amount over here, okay? Let's say we simply got amount larger than or equal to 0 versus amount larger than 0. Okay, I'll help you understand this. It's a simple one, but I think it deserves some attention over here. Think about these two conditions over here and see if you're convinced by the following. Okay, let's see over here. So we got P2 over here is amount larger than or equal to 0 versus we got P1 that is amount larger than 0. Okay, we want to know which one is more tolerant, right? Intuitively, think about this is the set for, let's say, P1. For example, P1 can be, let's say it can be 1, let's say integer, make it easy. Can be 1, can be 2, can be 3, can be 4, right? And now a question for you. P1 implies P2 or P2 implies P1? 1 or 2? First one? First one or second one? If you think that's the first one, sure. So if you don't think the second one is the case, give me a counter example.
Second one is
Give me, okay. So, okay, basically you're saying that if P1 is the case, right? If P1 is the case, that means P2 is not the case, let's say, okay? If P1 is the case, but P2 is not the case. Now I want you to give me one value for amount where this cannot be the case. You see that? So what about amount is equal to just 0? In this case, what do we get? If amount is simply equal to 0, that means it is going to satisfy P2, right? Because 0 larger than or equal to 0 will be true, right? And then P1 over here, when you have 0, 0 larger than 0 will give you false. True implies false, false. So that's a counterexample. More intuitively, if you think about a set of satisfying values for these two predicates, so now I already draw the set for P1. Do you think the set for P2 will be larger or smaller or the same? Strictly larger. If you think that's strictly larger, what would be the value that's included over there? That's outside of P1. Right? Exactly. So that means we got the value 0 over here. So which means 0 is going to satisfy P2, but not P1. Okay? That's just one simple example where you can say P2 is more tolerant than P1. It also requires less than P1. Guys, are we okay with this example here? Okay, we'll see more example in just a moment. Okay, I want you to just make sure you understand the definition when we say require less. Okay? Can I move on to ensure? Okay, now let's go to ensure. Yep. Now, let's talk about postcondition invariance. They are actually the same thing. Remember we said invariance basically like the postcondition for every feature. So postcondition, let's talk about postcondition only. Okay? Let's say we got two postconditions, Q1 and Q2. Okay? This is what we want to say. Okay? We define something here. This is what we say. We say Q2, the second postcondition, ensures more than Q1. So now, there's a very common misconception. Okay? When I say Q2 ensures more than Q1, I'm not saying the corresponding set for Q2 is strictly larger than the set for Q1. That's not what I'm trying to say. It's the opposite. Okay? When I say, think about it in this way. When I say Q2 ensures more, that means Q2 is actually somehow stricter. It has higher expectation on the output values. That means less output values can satisfy such higher expectation. That's what I meant. Okay? Make sense? So now, how do I formulate this in terms of set? If I say P2 is actually ensuring more than, Q2 is ensuring more than Q1, will the corresponding set for Q2 be a subset of corresponding set of Q1 or vice versa? Should be the set for Q2 is a subset of Q1, right? Okay, there we go. Okay, now, how do we use implication? Should we say Q2 implies Q1 or Q1 implies Q2? Q2 implies Q1, yes, exactly. Okay, now, I have a question for you. Okay, I do have one example there. I don't want to show you that. Let's be a little bit interactive over here. Let me give you two possible postconditions. Let me not say which one's Q1, which one's Q2, okay? Just two postconditions. First one, let's say I have a feature called Q, just a query. I have some integer value over there. And then it's going to return a Boolean. Okay? It's a very simple query. Let's not worry about the implementation. Let's only look at the postcondition. Okay? So now, postcondition number one. It doesn't mean it has to be Q1 or Q2. Okay? Number one. I say I equals, let me say this. The return value is going to be result. Result is going to be I equals 0, or I'll just put the or over here, disjunction, okay? Or I is even, modulo 2 is equal to 0. That's one, okay? Now, number two, I say result over here is I equals 0 and conjunction, okay? I modulo 2 is 0. Can you get any, can you tell me which one is stricter? 2 is stricter, right? Because of conjunction, which means both must be satisfied. And the first one is saying either one is okay. Okay? So now if you think about the set for 2, the set for 2 basically looks like this. And then the set for 1 is simply like that. Now let's do an exercise. Can anybody give me a value that is here but not here? Any value other than 0?
Number 2 doesn't have to be 0.
Mm-hmm.
So, number 1 should be any given number.
You should. Oh, actually, you know what? I think I meant to put positive. Yeah. Sorry about that. Yeah. Okay. That doesn't matter. Okay. Now we think about your example, right? So now, can you give me one example value that should be here but not in 2? Something that should be in 1. That can be in 1, but definitely not in 2. What? Okay, I heard 3. Okay, 3 is good because 3 is going to satisfy this guy here, but it's going to violate over here, right? Yeah, well, and is true when both are true, right? Yeah, basically any value that's going to satisfy only one of them, but not both of them, is going to be over here, but not in 2. Okay, so for example, 3 can be 1, or just simply negative number. Right? Negative number is going to violate this particular one, but, sorry, not yeah, so not this one here, -4, okay? It's going to satisfy this one here is an even number, and it's not going to be a positive number, but it still get true because it's disjunction. On the other hand, since it's negative, so this will be false, and overall it will be false anyway. Okay? Guys, do you see my point? Okay? But in general, you do know from your 1019, P implies Q implies P or Q. Right? It's a just direct application of the axiom or rule, theorem that you proved before. Okay, any question about this? We're okay, right? Good. Now, why am I talking about this? The reason is there is a particular way that we have to treat the pre and post condition in the context of inheritance by talking about ensuring more and requiring less. That's why we try to define these two notions first, and then everything else will be very smooth. Okay? Okay, let's go back here, and that's exactly the same example, the same. So inheritance and contracts. Okay, we'll do one more example in just a moment, but let's now see some concept here. This is our example from before, right? So let's say if you define, for example, my phone over here, my phone is simply a smartphone, right? And iPhone 6s Plus, Galaxy, HTC, they're simply descendant classes. And we said that we can simply substitute each one of them for the smartphone because they are descendant classes. That's what we said before. Okay? And the way we talked about before is because descendant classes are guaranteed to contain as least many code as the parent classes. That's why you can do the substitution. Basically, whatever you expect on the parent objects, it definitely can be satisfied by the descendant objects because they guarantee to define all the code. Okay? That's what we said before. But now, we want to basically say a little bit more logically for substitutability for contracts. So here are the two principles you have to remember. Okay? When we talk about substitutability, first of all, you want to make sure for any descendant classes that you're trying to define, they should not require more. Okay? And they should not ensure less. That's the principle. But let's try to get some intuition over here. First of all, let's see the first one. Let's say I only got two classes, A and B. Okay? A is on the top, B is the subclass. Okay? When I say the subclass B is not requiring more, so what do I mean? That means whatever precondition I can satisfy for A as a client, I shouldn't be shocked suddenly just because the descendant class B is requiring more from me. Okay, that's the intuition. Similarly, what do I mean by saying not ensuring less? Whatever that can be guaranteed from the parents as a service, for me as a descendant class, I must guarantee the same thing, but definitely not less. So I should really ensure more, okay? At least more. Okay, now let's see one example, okay? That's kind of the view for our classes over here. Let's say we got a phone user, so we got a smartphone, and then also we got, let's say we have a feature to consider. So the feature is get reminders. The get reminders is simply going to return a list of events, okay? And then we got require ensure, and also we got require else ensure then. Okay, so this is the only new syntax you have to learn. So require in the subclass, you got to say require else, and for ensure, you got to say ensure then. Okay, just to distinguish. Okay, so this is the parent class contracts, and this is the subclass contracts. Okay, so now what I will do is I will give you two versions of specifying the pre and post condition for the two classes. Let's decide which one is correct. Correct meaning that the descendant class can be substituted for the parent class. Okay, let's see. Okay, well, so I wouldn't tell you which one is which. Okay, first one. Okay, so now let's see this. Let's focus on precondition first. Okay, so what I would do is I have the feature called get reminders in smartphone. I also get reminders for iPhone 6s Plus. Oh, did I not switch that? Okay, sorry. Yeah, we got two classes over here. So we got smartphone, we got iPhone 6s Plus. Okay, you can see iPhone 6s Plus is a subclass, right, of the smartphone, and we have to get reminders, which will return a list of events. Okay, the same signature. Now let's focus on precondition first. Let me highlight it. over here, the precondition at the parent level is the battery level should be larger than or equal to 0.1, at least 10%. And the descending class level is simply is larger than or equal to 15%. Okay? Now, do you think the contrast is appropriate? Are you sure? I'm talking about design, of course. There will be a particular way to check this at the runtime, but I'm just talking about design. Does this make sense? Okay, how about this? Let's say this. This is alpha, right? This is gamma. Alpha and gamma. Let's refer to these two, alpha and gamma. So now, for gamma, does gamma require less or more than alpha? But the question is, I have two preconditions over here, alpha and gamma here, right? And then I'm asking, does the precondition in the subclass over here, which is gamma, does it require more or less than the precondition in the parent class? Less or more? More, right? Does it require more or less? Well, let's think it this way. Do I have alpha implies gamma, or gamma implies alpha? Alpha implies gamma? Don't guess, please. Yeah, you can take time to think about it. That's okay. Okay? 1 versus 2, right? Huh?
I think it's gamma implies alpha.
You think it's gamma implies alpha? Well, okay, well, let's say you're really not sure. How about we go down to the intuition, okay? Okay, so now, if you talk about, basically I'm asking the following, okay? Let's try. If I say number 1, what does number 1 mean? If number 1 is the case, that means I have alpha, the satisfying set, is going to be smaller than the set for gamma, right? On the other hand, if I choose for number 2, that means the set for gamma is actually smaller than alpha, right? Either way. Of course, if you say both are the case, that means they're equivalent. I can tell you they're not equivalent. But apparently they are not, right? Yeah. Okay, it's better? 1 or 2? Okay. Well, it's okay. Don't worry. There will be a standard answer, right, in the exam. So it's not really like a free form question, right? Okay. Let's say 1. If you think that's 1, okay. If you think it is 1, can you give me a value that's in gamma that will satisfy gamma but not alpha? 0.12. I agree. Okay. What about, okay, yeah, I agree. Okay, basically, any value between 0.1 and 0.15, right? Any value, right? That will satisfy basically alpha but not gamma. Okay? So now, let's go, okay, that's good. What about number 2? Is it possible to find such value? No, I don't think you can, because it's simply this is true. Okay? Okay, this is true, and this is how you prove it just to yourself. I wouldn't ask you to prove it, but you have to know how to get some intuition. Let's go a little bit further. Since we know, okay, are we okay with this counterexample for 0.12? Let's think about intuitively what this really means. That means if I'm a smartphone user, the smartphone package tells me that for me to get a reminders function to work, the battery level has to be at least 10%. Okay, now let's say my battery level is simply 12%. However, if I simply replace my smartphone by iPhone 6s Plus, it's going to crash because the 12% does not really satisfy the precondition over here. It does not, because it has to be at least 15%. You see my point here? So that means the logical relation over here is not right. Whatever precondition you have for the input values at a descending class cannot be requiring more. It must require less than the parent class. Okay? So this is not appropriate because it requires more than alpha. Okay? Are we okay with this? Okay? Good. Now, let's go for a correct version. What would be a suitable version? Over here, okay? Let's see over here. Let's say what we get is, let's say in the parent class, we got battery level this, and here we got battery level this. Do you think this is now appropriate? Again, let's ask the same question, right? Now, number one, we have alpha implies gamma. Number two, we have gamma implies alpha. Apparently, it's only one of them is true, not both. One or two? Please don't guess, but you gotta tell me hopefully the right answer. One, right? If it is one, so what that means is, are you sure it's one? Okay, let's say this is alpha over here, and this is gamma, right? Can you give me any value that is in here but not here?
0.05. Any value is less than 0.1.
Yeah, exactly. Okay, let's say 0. Maybe 0.7, for example. Let's say here, right? So what does that mean? That really means iPhone 6s Plus is exceeding what you can actually normally work for a smartphone, which is good, right? It's just requiring less on the input values. Okay? That's just the intuition I want you to get. Okay, postcondition. Okay? Postcondition is going to be a little bit trickier. Okay? But it's good to think about some challenging one. Okay, so now, apparently you know that this is the wrong version, okay? It's a wrong version. But let's see why it is wrong. Let's now highlight the postcondition using orange. Let's say we got here, and we got here. Let's first of all try to understand what it's trying to say, okay? For beta here, for beta over here, it's trying to say, it's going to give me, the result is simply the list of events, right? It's telling me every event in the result that I get reminded about should happen today. So I just get a reminder for today, okay? And then, if I look at this one over here, what is it saying? It's saying every event in the list of reminders that's returned, it can be either today or tomorrow. That is the very common misconception I think you might have. You might be thinking, well, potentially the delta over there, delta, might give me a bigger set. That doesn't really mean ensure more. It doesn't mean that way, okay? Okay, so now, is this appropriate or not? Okay, basically, again, let's think about logically, right? Number one and number two, okay? Do I have beta implies delta, or do I have delta implies beta? Beta implies delta, right? Okay, agree? Okay, I'm gonna leave that to you as an exercise, but let's go a little bit further. Okay, and tell you this is right. Well, I mean, for this particular example, that is the answer. So what does that mean? Let's get some intuition. If I know that beta is actually implies delta, what does that mean? If you think about this is the set for beta, you can think about this set is what you can expect from a smartphone, okay? And then you have this something over here as delta, okay? Yeah, let me just finish this and I'll take a question, yeah. So you can think about beta over here is the expectation for a smartphone. And the delta over here is simply the expectation for for iPhone. Okay, what we have right now is, for example, over here, it simply might just give me an event that happens tomorrow, right? What that means is, when I get my smartphone, I really expect all the reminders to be happening today. But the iPhone 6s Plus might just give me something that's outside the expectation, which is not good. It should be within the same expectation. Okay? Questions? Go ahead. Precondition.
We're not saying alpha implies gamma, right?
Alpha implies gamma. You know what? Alpha implies gamma is actually true for this particular example over here.
How's I don't, because 0.2 doesn't satisfy gamma. For gamma to be satisfied, it has to be greater than 0.15. 0.1 to satisfy alpha, but it doesn't satisfy gamma. So it has to be gamma implies alpha.
Interesting. Gamma over here. Oh, yeah, right. Oh, and nobody corrected me. But it's good that we corrected now, so it's recorded. So, okay, if you're watching the recording, you just gotta ignore what we said about that. But you guys are fine, okay? So, okay, let's make it right, okay? So I agree with you, okay? So now, and what you said before, Toppen, was actually right. Well, guys, next time, don't assume everything I say in the class is right, right? If you do believe I'm saying something wrong, do interrupt, okay? But let's do it properly. For the precondition, okay? For precondition over here, let's fix this and then I'll take your question. Unless you, something you want to. Only 10 minutes left? Wow. How about this? In order to really avoid any confusion, what I would do is, let's say this. What we just said before, to say this is actually the case, no, it's not the case, okay? So this should be the case. Let me review this in the beginning of Thursday to clarify everything, okay? But I do leave that as an exercise for you, also before Thursday, okay? But it's good that at least you guys can judge to see it's actually not the case, okay? I think I was just a little bit confused myself. Okay, lab 4. Okay. Okay, for lab 4. So what do you want me to talk about? Except for giving you the solution. Ask me questions. How about that? Yeah, go ahead. Lab 4.
So for the undo part, we can only undo once, right? But we're supposed to have like a hierarchy of levels. So how, like, so for example, if I have a list, and I don't know, like, I'm not sure what function to use if I wanted to do the undo more than once.
Okay, basically, how many times can you undo? Okay, let's say this. Let me just give a little bit quick overview of the runtime, and then go from there. You see if you have any questions. Basically.
Like if I was done part of the game and I wanted to undo all the way back to the beginning, how do I do that? So I want to just keep clicking undo.
Yeah, just undo for as many times as you that's needed for that particular stage. Yeah. Okay. How about this? I'll address this very briefly for what's going to happen at the runtime, and then you continue with questions. Okay. Let's say this. Let's say this is your AT100.txt, for example, right? That's your acceptance test. If I put, let's say, set number. Okay, just for example, let's say I put number 2, and then I got 1 and 3, doesn't matter. And then I will get also, let's say, start again. And also, after that, I'll say put number. Okay. And then I'll put, let's say, 3, and then I will say 4 and 2. Okay, doesn't really matter. Okay, let's say I only got 3 events in the acceptance test file. What's really going to happen at the runtime is, when I try to do, first of all, I assume you may have something for your model. I'll just call model over here. Whatever model class you might call. By the way, you can either call it ETF model, or you can call it Sudoku, whatever you like. Okay, I don't really insist on that. Let's say I do have a model object at the runtime. Okay, somehow I would expect model should be pointing to some history of the commands, right? Somehow, right? And then let's just go to execute one by one. When I try to do the first event, set number, what that would do is, first of all, it should really trigger the execution of ETF set number, right? So the corresponding query inside the ETF set number, you got something like a set number over here, right? Under the ETF set number. And then you got your normal if then else if, checks to see if there's any error to display, okay? Now, part of that should do the following. Part of that, first of all, you should really expand your current history by the corresponding command. Remember, one more thing to say. So we got our user command, cluster, and also we got our model cluster, right? And for this particular lab, what you're really required to do, you should really create another hierarchy of commands in the model cluster, right? Hopefully that's something you have done, okay? You may have something called command, and then under which you got the various command objects over here, just like the ETF command. You don't use the ETF command for the undo redo purpose. You don't really do that. Okay. So what I would do is over here for this part of the set number, it's more like the extension from lab 3. Okay. What you would do is I'm going to extend the history. Think about history just like a list. Okay, like a list. And then let's say this is the beginning of the list. Because the first one, I should really create a command for set number. So it's more like a polymorphic array, right? Where we talk about a state pattern, right? So now this should be an object of type set number, for example. Okay, that'd be the first one. And the cursor, is pointing to here. Hopefully this is something you have done already, right? Okay, I hope, okay? I really hope that at the end of the day, you're thinking I'm wasting your time because I've done that already. I really hope, okay? Okay, that's the first one. And the second one is going to be start game. Okay, the second one is just going to be, we're going to execute the corresponding code from ETF start game. And then under which we also got a start game feature, right? And from there, also one part of that, you should really create a new command object of the right type, which will be for the start game. That means the second one is going to be of a different dynamic type, start game. Okay, let me do one more, and then we can talk about undo redo. After that, let's say we do the third event from the acceptance test. Again, accordingly, you should really create just another one. Let's say that one there is simply of type put number. Okay, different dynamic type. Okay, so now the cursor should already be pointing to the last one, right? So now, how do we do undo redo? Basically, according to the chapter, for the command class over here, you should have undo, redo, and also execute. Good, I'm glad you know that. Okay, execute. Okay, assuming that you already implement those. Okay, now if I say undo over here from the acceptance test, what that would do is it's going to trigger the fragment of code for ETF undo. And what that would do is you should really have a way to go to the, not really go to, whatever cursor that is being pointed to for this history array, you should just go to, for example, you want to say history dot item dot, for example, undo. Because dynamic binding, this dynamic type is simply just put number. So it's going to undo the put number. After that, you should really also move the cursor to the left by one position. And one thing to note, you should not delete any of the objects for now, right? You only delete the object when what? When you try to do another events, right? Okay? Yeah, I think that's pretty much it. Of course, you want to make sure you can keep undoing until the cursor has nowhere else to go, in which case you would say nothing else to undo. And similarly for redo. Okay, guys, that helps, I hope. Okay, the project will be released today. One thing to notice, okay, just give me another 1 minute. So project will be released tonight. So notice that you got this Wednesday, next Wednesday, the Wednesday after you got your lab test. Okay, make sure. Okay, so I will be in both of the lab tests. I will be in both of the lab sessions this week and next week to help you with the projects. Make sure you start early. Okay, I'll see you tomorrow.